In this video, I will show you how you can calculate the inverse of a matrix using the cofactor matrix and the adjunct. In particular, I will apply these methods to a 2 by 2 matrix and a 3 by 3 matrix. Let's start with the 2 by 2 matrix. If you have matrix A, which is equal to 2, 1, 1, 2, you might already know that the inverse is simply flipping the diagonal elements and taking the negative of the off-diagonal elements multiplied by the determinant of A. In that case, the inverse is simply 2 minus 1 minus 1, 2 times 1 over the determinant of A. The determinant of A is simply 2 times 2 minus 1 times 1, which is 4 minus 1 equals 3. However, we have not applied the method I said in the beginning, so we haven't calculated the cofactor matrix or the adjunct. So let's do that. The cofactor matrix has special elements. The formula to get each of those elements is simply C I j is equal to minus 1 to the power of I plus j times mij, where mij is the minor of the matrix, which means that you delete column I and row j, and you take the determinant of the remaining matrix. So let's do that with this matrix. So the first element is 1, 1, so there's no negative sign because it's an even number. So we need to find the minor. We delete column 1 and row 1, and we're left with the element 2. Now we can repeat that with the second element down here, or here, and we know the indices are 2 and 1, so they sum up to 3, so there's a negative sign. Deleting column 1 and row 2, we're left with the top right element, which is 1, and we repeat that with the top right element, which has indices 2 and 1, so again there's a negative sign. We delete the second column and the first row, and we're left with element 1. And lastly, we have the element down here, which has index 2, 2, an even number if you sum them up. And we delete the column and the row, and we're left with 2, which gives us our cofactor matrix. Now to get the adjunct and the inverse, we need to transpose this matrix. So we calculate C prime, which in this case is the same as C because it's a symmetric matrix. So 2 minus 1 minus 1, 2. And the inverse of a matrix is simply this transposed matrix of cofactors times 1 over the determinant of A. So let's apply this now to a 3 by 3 matrix where we actually need to do this calculation unless you know the complicated formula which can calculate it directly. Let's start with the following matrix. 1, 1, 0, 1, 0, 1, and 0, 1, 1. Okay? And we want to get the inverse. Now we can already calculate the determinant of this matrix, which we immediately find. So all the diagonal elements here, the falling diagonals will be 0, and the raising diagonals are twice 1, so the determinant of it is minus 2. Okay? So now let's find the matrix of cofactors. Again, we apply this formula. We start with the first element, which has index 1, 1, that sums to 2, an even number, and we delete the first column and the first row, and we're left with this matrix here, which has a determinant of minus 1. Now we do the same with this element here, which has index 2 and 1, so there's a minus sign. and we delete column 1 and row 2, and we're left with this matrix here, which has determinant 1. So we have -1 here. The last element down here has indices 1 and 3, so there's no negative sign. And we delete the last row and the first column, and we get the determinant of 1. We continue in the middle of the top. The indices are again 1 and 2, so as for all these 4 elements, there will be a negative sign. Let's delete the first row and the second column, and we're left with this determinant, which has a value of 1. The middle element leads to an even number because the indices are 2, 2. Delete the row and the column, and we have determinant 1. The bottom one, again, sums to a negative number, so we have the last row deleted and the middle column deleted. Determinant is 1, so we get -1 here. Last column, this element is 1 and 3, so it's an even number. Delete row and column, we get 1 here. The middle element has a negative sign, so we delete said row and column, and we get determinant of 1. And the last one, which has again an even number as the sum of the indices, so we delete the last column and the last row, and we're left with a determinant of -1. As in the 2x2 case, we now need to transpose it to get to the adjunct. So let's transpose this matrix here. The diagonal elements stay the same. -1, 1, -1. We go with the off-diagonal elements, and we need to flip those two, which don't change, those two, which don't change, and those two, which actually don't change, so it's quite nice. So transpose of this matrix is actually the matrix itself. And we found our inverse of A by simply multiplying this matrix times 1 over the determinant. Thank you for watching.